In this video, we're going to explore in depth the new function calling with GPT API. We will start with a simple example from their documentation and then move on to a more complex SQL querying example over Chinook music database. And finally, we're going to move on to an even more complex example downloading scientific papers from Arxiv scientific database and then doing simultaneous summaries of them and chunking and all of that. This is going to be a long video, but we're going to be learning a lot of cool stuff, including how the functions work. We're going to dive deep into how we can get these functions working. We will learn about using Tenacity to do exponential retries so that when our functions fail, we can get them to retry. We're going to learn how to use SQLite3 to connect to a database and make queries over it. We're going to learn about how to create function schemas for GPT. We're going to learn about how we can try to incorrectly return SQL queries by making a secondary call. We're going to create a super cool class called Conversation to manage our conversations with GPT. We're going to learn how we can embed documents or anything we like directly into a CSV file so that we can use it without any external libraries or anything like that. All of this is going to take place with pure Python and its libraries. We're going to do similarity search and rank them. We're going to use PDF Reader from PyPDF to deal with PDF files. We will be creating chunks using TikTok and Tokenizer, and we are going to be summarizing documents, each one of the chunks simultaneously using concurrent features, thread pool executor. And we will be learning how we can define multiple functions for GPT to use. So let's begin. You can find these examples at OpenAI's cookbook. I'll put the link in the description. But I have copied and extensively commented all the code. For convenience, they will be available. All the code files will be available at my Patreon. Link will be in the description. So let's begin with the simple case. We are importing OpenAI, JSON, and OS. We are checking our OpenAI API key. You can also explicitly define it here. And we are creating a dummy function for getting current weather. This is not a real function, but it just has information already in it, defined as weather info, that the weather is 72 degrees and sunny and windy, and then it just returns that information. Then we have a function called run conversation, in which we are making an OpenAI call to the new GPT-3.5.turbo 0613, which accepts functions. We have our messages as normally we would. We are asking what is the weather in Boston, and we are defining a function schema. As you see, we give it a name, a description, and parameters. Parameters are going to be what the function takes as input and output. Now, mind you, this is not the function itself. This is like a schema definition of the function. It says the location is a string, description is the city and state, for example, and unit, which this function takes, is string, Celsius or Fahrenheit. Location is required since it takes in that as input. And we're setting the function call to auto. You can actually specify the name of the function if you want to force it to call a particular function. So this is going to be our call, and then we're going to make a call, get a response. I've actually put a breakpoint here. Let's run this function with the debugger. I'm going to press F5, or you can initiate the debugger from the run and debug as well. And then right when we come to this line 46, our execution will halt so we can see what's happening. So we are querying GPT with what is the weather like in Boston. So now we are going to actually print the message. Okay, let's see what it is. It says, see, the assistant is returned. There is no actual content because it's returning a function call this time. And it says, okay, we want to call the function get current weather with the argument location being Boston. Okay, so this is the only thing that it had returned so far. So then we have a checking mechanism. We check if message.get function call, which is true. So because the function call is not null, it has content. Then we extract the function name as the message's function call, see right here with the name key, which is the get current weather. When we extract that, our function name is get current weather right here. And function response is going to be, we are going to call this function by adding the location and the unit from the message right here. We're going to retrieve the location. And there's no unit, but unit wasn't absolutely required. So we get a function response. See, function response is the temperature 72 and forecast sunny and windy, which was exactly what our function was supposed to return. And then we are going to query again with the GPT-3.5.turbo 0613 with again what is the weather like in Boston. But this time it has the information which is returned from the function response. And when we do that, see, content includes the function response right here. And when we make our second call and then print it, we see that we get the entire response object, and it says the current weather in Boston is sunny, windy with a temperature of 72 degrees Fahrenheit. So this is how the functions work in a nutshell. Now let's move on to the more complex SQL example. All these code files will be available at Patreon for convenience, along with 90+ other project files. If you do like my work, feel free to support me, and you will be able to take advantage of some exclusive posts and code files here. I also want to mention you can search and watch all my videos that I've created, over 140 of it, at echohive.live. Take a look. Link will be in the description. So now let's move on to our SQL example. For this example, you will have to download the Chinook.db database. You can download this from the SQLitutorial.net. Right here. I'll put the link in the description. I'll also put the database in the Patreon post as well. We begin by doing all our imports. The requirements for this file and the archive file is quite extensive. These are the requirements, which will also be available at Patreon. We are defining our GPT model as the new 3.5 Turbo. You can also use the new GPT-4 as well. Defining our API key, and we are using a decorator from Tenacity with exponential backoff. What this does is that when we call this chat completion request, in which we are making a call to OpenAI fails for any reason, it will wait anywhere from 1 to 40 seconds, and it will try this 3 times, but increasing the time it waits exponentially each time. If for any reason this function returns an error. So we are defining this function, which is going to do a request API call to OpenAI chat completions. It's going to take in messages, functions, obviously, which we are going to define, and the model name, which we have defined right here. And our headers is going to be application, authorization is the bearer, which is our API key. JSON data is actually the model and the messages. This is all to be able to actually insert to the request. If function is not none, then the JSON data update functions is functions. That means if we have defined functions, then we add it to the JSON data, and when we have a try and accept block in which we are going to try to make a request chat completions with the headers and the JSON data which we have defined right here. And then we're just simply going to return the response. If there's any errors, then we're going to say unable to generate chat completions, and we're going to print that error. And this Tenacity decorator is going to allow us to try up to 3 times. And this part is pretty cool. Here in the cookbook, they define a conversation class with a conversation history list, which is being empty, and it has an add message method, which actually starts with it's a message populator, which is designed in the exact same way the GPT interacts with the messages. And then conversation history is appended like this, so we can add messages using this method. And display conversation is pretty cool. With this method, we can actually print the conversation history for messaging conversation history using the term colors colored. And here they have created a dictionary of the colors, like system message will be red, user will be green, assistant will be blue, and functions will be printed in magenta, pretty much like purple. And here with this F string, we are printing the message, also the whatever color that message should be printed in. So I thought this was pretty cool. Anyway, so then we are creating a connection object to connect to the SQLi3 database, to the Chinook.db music database, which is under our data folder. And once we do that, we print that output data we have connected to the database. Then we have these helper functions, get table names. This actually returns the list of table names from the database. Column names returns the list of the column names, and get database info actually combines the table names along with the column names and returns the table's dictionary. We are going to be feeding this dictionary to our prompt within our prompts so that GPT will know how our database looks like more or less. So then we call this get database info, which actually calls then the get table names function and get column names function, which we have defined here, and returns the database schema dictionary. And then with this line, we actually take this database schema dictionary and turn it into a string by joining all the names using a list comprehension for looping. And then this is what we are going to be feeding to GPT. And then we are defining our function schema. Here we are saying that notice that we are inserting the database schema into the function. So let's take a look at this function. Its name is ask database. Use this function to answer user questions about music. Output should be fully formed SQL query. Because the function is going to return a SQL query, which then we can use to query the database. So it's going to take in string. Description is SQL query extracting info to answer users' questions. SQL should be written using this database schema. And then here we are inserting the schema string, which we have created here. The query should be returned in plain text, not in JSON. Okay? So this is the schema which we have defined. And then now we are defining the actual function to query SQLite database with provided SQL query. Con is the connection to the SQLite database. Query is the string containing the SQL query to execute on the database. This is going to be a SQL query, right? And it returns a list of tuples containing the results of the query. So we try to do that. We do con.execute that query, fetch all, and then return the results. Otherwise, if there's an exception, we print that error. And then here we have a function, which is the chat completion with function execution, which is going to take in our messages and the functions, currently none. It says this function makes a chat completion API call. If a function is requested, executes the function. Okay, it takes in the messages and the function. Functions, the optional list of dictionaries, right? We have defined it right here. It only has one function so far. So then we try to make a chat completion API call using messages and the functions. And then we get a full message, and then we get the message. And if full message finish reason is function call, and we say function generation requested calling function, then we call that function and return the result. Otherwise, we print function not required responding to the user, and then we just return a regular response object as we would normally do. If there's an exception, we actually print it into the console. Now here's the call function. If GPT decides to use a function, then we're going to execute this call function, right? Takes in the messages and the full message, executes the function call using model-generated function parameters. So we take a look at the full message. If the function call name is ask database, then we are going to execute that. But here we are actually first taking the query out of the arguments, which the GPT is going to return. And we are printing what our query is going to be. And then we try to ask database, which is the function which we have defined up here, right? It takes in a query, and query is the SQL database. So we are going to query the database right here, try. If there's an exception, however, this can be because the GPT maybe returned an incorrect SQL query. This could be one of the cases. So if we say, if there's an error in the query, we're going to try to fix it with a subsequent call. So if just in case if there's an error, right, since especially we're using GPT-3.5.turbo, then we are saying that we, with an F string, as a system message, we enter, okay, this is the query. And then we say the previous query received the error, which is the error, which we are receiving right here. Please return a fixed SQL query in plain text. Your response should consist only of the SQL query with the separator SQL start at the beginning and SQL end at the end. So we are hoping that the SQL query will be squeezed in between these keywords. And then we retry to make, again, this time to GPT-4, right? So we tried originally with GPT-3.5. If it fails, we make a call to GPT-4. And then we get a response, and then we try to extract the SQL clean query by looking at where the SQL query start is. And then we take the second element because this splits the string from where the SQL start is. SQL start becomes the first element, which is the 0th element, and the rest of it is the first element. And after that, we again split it at SQL end. SQL end, when we split it SQL end, then whatever the query itself will be the 0th element, and SQL end will be the element after that. So we take the 0th element, and now that's our clean query. We print it, and then we again use the ask database function with that clean query and get a result. And then we print that result, and then we say that we are successful on that try. And if we fail for any reason, we say the second failure, exiting, because we only try twice in a maximum. And then we simply append the result to the messages list, role as a role with the function, and name, which is the function name, and the content, which is the result. And then we again make a call to Chatgpt with the updated messages list. We enter the messages and we get a response, and then we return the response.json. There's an exception. We say that function chat request failed. Okay, and then we defined our main agent system message. Your Chinook, I hope I'm saying this correct, Chinook, or I'm not sure. GPT, a helpful assistant who gets answers to users' question from the Chinook music database, provide as many details as possible. Then we initiate the SQL conversation instance from the conversation class, which was defined all the way up here, right? And then we add to the SQL conversation the system message, which is our main message right here. And then we add another user message by asking, hi, who are the top 5 artists by number of tracks? And then we make a chat completion call with function execution right here. And then we try to extract the assistant message, and then we print it, okay? And then we add that message, and then we use the display conversation method to display it colorfully. And then we make a second request, what is the name of the album with the most tracks? And then we make another call, and then we print that as well. So now if we run this, you'll see we opened the database successfully. We are connected to the database. We get a query. This is our query. And so we had good luck. Said the first query actually worked. And then this is the response: top 5 artists, Iron Maiden, U2, Led Zeppelin, Metallica, with however many tracks they have. These artists have a substantial amount of music recording available in the database. So this is our response. And we successfully executed the function which retrieves information from the database. So then the next display conversation is going to display this conversation colorfully and more in detail. So the user system message is printed here, which we have read. We are asking who are the top 5 artists, and the function returns this result from the database. And then this is summarized to us by the assistant in this way. And our second question was, I believe, which album has the most tracks? And we again get a query successfully, and we get a response. The album with the most tracks in the Chinook music database is Greatest Hits, which contains a total of 57 tracks. So this is really pretty cool to me. I really enjoyed going over this. Next, let's take a look at the archive example. If you are enjoying my content, take a look at Patreon, where I offer code files and exclusive content with over 90 plus posts. And also at echohive.live, you can search all my videos, watch them, read their descriptions, and find the code download links. Echohive.live. So our next example is how to actually query and summarize and answer questions over scientific papers, which we are going to download from Arxiv. This is really extensive. We are utilizing PyPDF, SciPy, all kinds of stuff like tick token, concurrent, so to make summarizations concurrently, like we did in one of the videos. Anyway, so we have all our necessary imports. We define our model as GPT-3.5, the latest model, and embeddings is going to be the text embedding 8002, the newest one, right? It's the same one, but now its price has been reduced by 25%. We are defining our API key. We are importing Tenacity for exponential retry and backoff, and import request to make our call. Again, we have our Tenacity retry decorator, chat completion request, as we have discussed earlier. We have our conversation class, as we have discussed in the SQL example. Now here we are going to download some papers from Arxiv automatically. Downloaded papers will be stored in a directory, data and papers right here. Okay, I'm actually going to go ahead and delete these papers and delete the embeddings as well. So we have a data folder which has the music database, which we have used for the SQL example. But then we also have an empty papers folder, just like this. Okay, and we are going to create an archive_library.csv because we're going to be storing the embeddings for the titles here. Because we're gonna query those titles and then pick the most relevant paper, and we are going to summarize the text of it. So this is where we are doing that. Set a directory and store the downloaded papers, and we create an empty archive library text. Let's actually run this in debug mode so we can see what's happening real quick. This is just going to take a second. So we have executed the code until here, and we have created right after this a blank CSV file. We're going to be storing the embeddings here in a moment. So we are doing these. Next up, again with the tenacity decorated, the embedding request, which takes in some text, and then it actually turns into an embedding, which is our response, and it just returns the response. So this is just an embedding function. Our next function is get articles, which takes in a query and takes in a library, which is our file path, which is whatever paper we're dealing with. And sorry, it just takes in the path of the library. And then here we are defining our top K, because this is like in this case it's set to 5, so we're going to be downloading 5 papers, up to 5 papers from Arxiv search. So it says this function gets the top K articles based on the user's query, sorted by relevance. It also downloads the files and stores them to archive library.csv to be retrieved by the read article and summarize function, which we're going to take a look at here soon. So we search the articles based on the user's query. We use the archive library, which we have downloaded. They're using their API. We get the max results, sort by the sort criteria. So we are relying on our archive API to sort it for us. Then we make a result list, and then we go over the search results, and then we add the title and summary article to the result dictionary. We create a result dictionary. We get the title and the summary. We add it to that. And then we take the URL, add the article URL and the PDF URL to the result dictionary right here. We store the references in library file, get the text embedding for the article. So then here we get a response from embedding request text. So we will be only embedding the titles of the articles. Okay, just keep that in mind. And then we create a list with the article title, downloaded PDF file path, and the text embedding. So this is just a reference we are creating with the title, with the file path and the embedding, okay, of that title. And then we are writing it to our CSV file, and then we return the result list. So this is what this function get article does. Now we can actually test this. I'm actually going to uncomment it right here. When we try this, we are going to be querying Arxiv for PO reinforcement learning. PPO stands for, I think, proximal policy optimization. Anyway, let's run this with F5 in debugging mode. As you see, we are now downloading the papers. The second paper is downloaded. Third one. Fourth one, and I believe we're going to download a total of 5, and then we're going to print the first one's summary. I believe it's the title and the summary, along with the PDF URL. So this is from our list. Our next function is strings ranked by relatedness. This takes in a query relatedness. We are going to use the SciPy spatial library to do cosine similarity, okay, with an inline list comprehension style. And then what this is going to do is return a list of strings and relatedness sorted from most related to least related. Here's the definition of articles. The number of top results to return here. And then this returns a list of strings sorted by relatedness to the query string. So what we're going to do is we are going to take the user query, right? Now we're going to download, as we have done, all the top 5 related articles from Arxiv. And then we have actually taken their title and turned it into embeddings, as you see right here. And then in this function, we are going to take the query, and then we are going to actually check its relatedness against the title of each one of the fives. And then we are going to get a string and relatedness list. After which time we're going to sort it in the most related, and then we're just going to simply return that. Okay, this is what this function does. So this queries the embeddings of the titles against the user query and returns whichever ones are the most relevant. And then we have a simple read PDF function, which just reads the PDF, which is going to whichever file path we specify. And then we have another function called create chunks, split the text into smaller chunks of size n, preferably ending at the end of a sentence. So I really like this function because it's pure Python using token. We say tokenizer and encode text, right? This takes in text and tokenizer, and is the size of our chunks, token size, and our tokenizer obviously is tick token. So what we're doing is find the nearest end of the sentence within a range of half and 1.5, whatever tokens are. So essentially what this checks is whatever chunk size we have specified, it tries to find the nearest, for example, dot or a new line. Say decode the tokens and check for full stop or a new line, which we are doing right here. If no end sentence is found, then use exactly the chunk size. So this is pretty genius in my opinion, written in pure Python. So after that, we extract the chunks, right? This function applies a prompt to some input. So this takes some content and some template prompt. So the actual prompt that this function is going to be creating is the template prompt, which we are going to feed into it, and then the content. And then the content is going to be one of our chunks, for example. And then this makes a call to GPT with that prompt, temperature 0, and just returns the response. You're going to see what this all means here in a second. And then we have a summarize text function. This function summarizes text from an academic paper. See, this function does the following. Reads the archive library CSV file, including the embeddings. Finds the closest file to the user's query. Scrapes the text out of the file and chunks it using these functions. Summarizes each chunk in parallel using concurrency. Does one final summary and returns it to the user. So this is the prompt to dictate how the recursive summarizations should work. Here's the summary prompt. Summarize this text from an academic paper, extract any key points with reasoning, and then it says content equals, okay? So if we come back to the extract chunk function here, we were saying the template prompt. So this is our template prompt, right? It says content, and then plus the content. So this essentially says whatever, and then whatever the content is goes underneath it. So if the library is empty, then we perform and download the results right here. Rename the columns, so title, file path, and embeddings. Convert the embeddings column from string to list, right here. Find the closest file to the user's query. We call the strings ranked by relatedness, which does the similarity search, and then we return the strings. And then it says chunking text from paper. Then we read the text from file using the function read PDF. This is going to be our PDF text. Initialize the tokenizer, tick token get encoding, which is CL. This is the Chatgpt tokenizer, I believe. We initialize a result string, and then we create chunks in 1500 token counts, giving that PDF text as our content. And then text chunks is going to be tokenizer, so we do list comprehension. And then summarizing each chunk of text. Because now we have created our chunks, now we're going to get parallel process the summaries, because we're going to get a summary for each chunk. We are creating a thread pool executor with maximum number of workers equal to the number of text chunks, okay? With concurrent features, thread pool executor, and then submit a task to the executor for each chunk right here, and then create a progress bar. This is pretty cool, pbar.update, tqdm, which we have imported all the way at the top, as pbar, progress bar, for each one of the concurrent threads completed. Then we're going to update that bar by 1, concatenate the results into the whatever summaries into a single string, and then print final summaries. We're going to say summarizing it overall. We make one more call, write a summary collated from this collection of key points extracted from academic paper. The summary should highlight the core argument, conclusion, and evidence. The answer and answer the user's query. User query is here. Summary should be structured in bulleted lists following the headings, core argument, evidence, and conclusions and key points. And then we give the results, which are the summarized chunks. And then we ask for a summary, and then we get a response. We can actually test it as well. I put a breakpoint right here, and and here is the summary, core arguments, evidence, and conclusions. This is really pretty cool, in my opinion. Now that we know our summarized text functions work, we're going to initiate our get articles and read articles summarize functions schema is defined. So we say archive functions is going to be, the first one is it's in a list, get articles, and the second one is read articles and summarize. First one's description is use this function to get academic papers from Arxiv to answer questions. And it's the query is the user query in JSON. Responses should be summarized and should include the article URL reference, just in case if the user wants to use it. The read article and summarize says use this function to read whole papers and provide a summary for a user. You should never call this function before get articles has been called in the conversation. And it queries the description of the article in plain text based on the user query. Okay, so now we have defined our archive functions. Then we are defining a chat completions with function execution, which takes in messages and functions. This function makes a chat completions API call with the option of adding functions. And we make the call with those, get the full message, and then we check if the full message is finished reason is function call, then function generation requested calling function, and we call the call archive function with those messages if there's any problems. Otherwise we just return a regular response. And we are defining the call archive function. This function calling function, which executes function calls when the model believes it is necessary, currently extended by adding clauses with if statement. So this part was a bit confusing to me because we are not really allowing exactly, we are allowing GPT to pick either to use get articles and read articles and summarize, and then we are then using the call archive function with conditional if statements to see which one of these get articles or summarize text to be executed. So anyway, when we are defining the call archive function, right, we get the full message of the response, function calls name. If it is equal to get articles, then we try to parse get the arguments, hopefully, with JSON.loads, loads. Then now we have our parsed outputs, and now we are getting search results by running the get articles function with the parsed outputs query, okay, since it's going to be a JSON object, and we get a result. If there is an exception, then we say function execution failed. Then we append the results of the function, and then we try got search results summarizing content. Then we call with the messages, and then we get a response in this case. But this was when the GPT returns the function to call get articles, okay? Otherwise, we say if the return from the GPT is read article and summarize, then we again parse the outputs, and then we call the summarized text and return the summary. Now we start, okay, now so these were all definitions. Now we have all our definitions ready. Now we create our main prompt. You are an archive GPT, a helpful assistant, pulls academic papers to answer user questions. You summarize the papers clearly so the customer can decide which to read to answer their questions. You always provide the article URL title so that the user can understand the name of the paper, click through it to access it, begin. And our paper conversation is the conversation class, right? If you remember all the way in the beginning, which we have defined the conversation class with the add message and the display conversation methods. Okay, and then we say add message system, paper system message, which we have defined right here. And then we add a user message. Hi, how does pure reinforcement learning work? And we make a call to GPT. And we give our conversation history, which is the system message, and our question. And we assign it the archive functions, which we have defined up here, the function schema. And then assistant message is whatever we are returned. We simply add it to our messages, and then we print the assistant message. Now let's just run this again in its full. When we run this again, now we are executing this final I have commented out our tests earlier. Now this is downloading the papers. Each time, again, we can put a check to see if a file exists that we don't download it. But anyways, now we have gotten everything. We are summarizing each chunk on parallel using concurrency. So this is a long paper. And then we are summarizing into overall summary. Here we go. We got our summary right here. A few things to mention is that we have downloaded the papers, we have created embeddings, we have saved the embeddings into CSV file. So, I mean, I really enjoyed this implementations because I learned a lot of little things. So I'll be reviewing this code for some time to come and actually try to learn from it. I hope you found this helpful. Like I said, if you're enjoying my content, make sure to visit echolive.live and find the content you like to learn about. Thank you for watching and see you in the next time.